Alright, in this video we'll be looking at graphing inequalities. At this point we've seen how to graph equations in the form y equals mx plus b. That's what we call the slope-intercept form. Now what we're going to do is we're going to replace the equal sign with an inequality symbol. And I've got four different variations that we'll be seeing here. We've got y is greater than mx plus b. We've also got y is less than mx plus b. Number 3, we have y is greater than or equal to mx plus b. And number 4, we have y is less than or equal to mx plus b. So again, inequalities, we're replacing the equal signs with an inequality symbol. That's the less than or greater than symbol. Now, just like we did with the equations, we need to make sure that we do keep in mind that m does stand for slope still, and the b is still going to stand for our y-intercept. So that's not going to change anything. We're going to keep that part the same. Where it'll be different is when we start adding some shading to our graphs, and that's going to have to do with our inequalities. But I'll get to that once we start looking at some examples. As a matter of fact, let's go ahead and take a look at our first example. Alright, here's our first example. We've got y is greater than 2x plus 3. We're going to start off by treating this just like we did with our equations. We're going to start by finding the y-intercept, which in this case that y-intercept is at 3. That's this value right here. So we're going to come over to our graph and find the y-intercept 3. That's this point right here. The next thing we're going to have to do is find the slope of the line, and that can be found right here. The slope of our line is 2. But recall we did define slope as rise over our run. So I'm going to make our slope a fraction, and we can turn that 2 into a fraction simply by putting a 1 underneath it. So now we have 2 over 1. So now that I know my slope is 2 over 1 from that y-intercept, I'm going to rise 2, then I'm going to run 1. So it's up 2 and then over 1. Remember, we're going to repeat this pattern because the more dots we have, the more accurate the line is. I can get some other dots in the other direction by reversing the pattern, going down 2 and to the left 1, down 2 to the left 1, down 2 to the left 1. Again, the more dots we have, the more accurate the graph is. Now we're going to have to be careful here. Before I connect the dots, we need to keep in mind that sometimes our lines are going to be dotted and sometimes the lines are going to be solid, and that's all going to depend on our inequality symbols. So here's what we're going to have to watch out for. If we have a greater than or a less than symbol, what we're going to use is a dotted line. Now if we have the greater than or equal to or less than or equal to, we're going to use a solid line. Now in our particular case we have the greater than symbol, so what we're going to do is connect these dots with a dotted line. And I'll talk about what the dotted line represents here in a little bit. The next thing I'm going to have to do is some shading. Now that shading again is going to depend on what inequality symbol we're given. If we have the greater than or the greater than or equal to, what we're going to do is we're going to shade to the top of the line. If we have the less than or equal to, then what we're going to do is we're going to shade to the bottom of the line. Now as you can see in this case we do have the greater than symbol, and because of that greater than symbol, what we're going to do is we're going to shade everything to the top of our line. So that would be this part right here. So what we're saying with this graph is that any ordered pair that's inside the shaded area is going to represent a solution to this inequality. For example, this point right here, it's inside the shaded area, therefore it represents a solution to this inequality. This point over here, that is also in the shaded area, so it also represents a solution. Now, if I had chosen a point out in this area, well, that's not inside the shaded area, therefore it's not a solution to the inequality. So it's only the points that are inside the shaded area. Now, what about if it falls on top of the line? Would we consider it a solution or not a solution? Well, that's where the dotted and solid line comes in. If it happens to fall on a dotted line, as it does in this particular case, like this point right here, in this case, because it's on a dotted line, it would not be considered a solution. We're only going to consider it a solution if it falls on top of a solid line. So it's going to take a little practice getting used to when it's a solution and not a solution. Just remember, if it's on a dotted line, it is not part of the solution. But if it falls on top of a solid line, then it is part of the solution. Alright, our next example, we have y is less than negative 3x plus 4. We're going to start with the y-intercept, and that y-intercept for this inequality is 4. So I'm going to start right here at 4. Now I'm going to need my slope, and the slope in this equation or inequality is negative 3. But I'm going to write that as a fraction, so I'm going to rewrite that as negative 3 over 1. So from my y-intercept, my slope is telling me that I need to go down 3 and 1 to the right. So that's what I'm going to do next. I'm going to go down 3, 1 to the right. Down 3, 1 to the right. I'm just repeating the pattern. Down 3, 1 to the right. Down 3, 1 to the right. I'll get a few more points on the other side by reversing the pattern. We're going to go up 3, 1 to the left, up 3, 1 to the left. Now don't get in a hurry here. Remember, sometimes we use solid lines, sometimes we use dotted lines, and that all depends on the inequality. This time what we have is a less than symbol. So that less than symbol, as you can see from our notes down at the bottom, purple, says anytime we have a less than, we're going to use a dotted line. So that's what I'm going to use to connect these dots, is a dotted line or a dashed. The next thing I'm going to need to do is shade. Now if you look at the inequality symbol that we have this time, it's a less than symbol. And if you look in yellow down at the bottom, it says anytime we have a less than symbol, that we should shade to the bottom of the line. So I'll be shading this area right here. So once again, any point, and there's lots of them, any point that falls within the shaded area represents a solution, such as this point right here. That's a solution. This point here, that's a solution. Any point that's inside the shaded area represents a solution. Now, of course, the next question is, what if it falls on top of the line? Such as this point right here. Well, remember, if it falls on top of a dotted line, it is not considered a solution. So any point that falls on top of that dotted line is not a solution to the inequality. Example number 3, we have y is greater than or equal to 1/2 x minus 3. We're going to start with the y-intercept, and the y-intercept in this inequality is negative 3. So that's where we're going to start from, right here at negative 3. Next thing I'm going to look for is the slope, and the slope in this case is 1/2, which means I'm going to need to rise 1 and run 2. So we're going to go up 1 and over 2. Up 1 over 2. Up 1 over 2. Repeat the pattern as many times as you can. You can get some other points in the other direction by reversing the pattern. Going down 1 to the left, down 1 to the left, down 1 to the left. Notice how all the dots line up. Next thing I got to do is decide what type of line I'm going to use to connect these dots. You'll notice the inequality symbol we have here is greater than or equal to. Key thing here is if you see that equal sign, we're going to use a solid line. So that's what I'll be using here, solid line, and that's because of the equal sign. The last thing I'm going to need to do is shade. Question is, which direction am I going to shade? Well, notice the inequality symbol we have here is the greater than. Anytime we have that greater than symbol, we're going to shade to the top. So we're shading everything above the line. So once again, anything that falls within inside this shaded area, such as this point here, any point that's inside the shaded area represents a solution. What if we choose a point that's on the line itself? Well, this time, because it's a solid line, we can say that it is part of the solution. So this point here, this point here, this point here, they're all solutions to this inequality, and that's because they fall on top of the solid line. And that's the reason we're using the solid and the dotted line, so we can distinguish when it's a solution and when it's not a solution. Let's go ahead and take a look at one more example. Alright, last example we're going to look at is y is less than or equal to x. We're going to start with the y-intercepts. Now notice we don't have a value after the x, therefore we have a y-intercept of 0. So we'll be starting right here at the origin. The slope, in this case, is the value in front of the x, which you can't see, but it is there. It's a 1. But since I'm defining slope as rise over run, I'm going to turn that 1 into a fraction by putting a 1 underneath it, which means I'm going to rise 1 and then run 1. So that's what I'm going to do from my y-intercept. We're going to rise 1, run 1. Up 1, over 1. Up 1, over 1. Remember, the more dots you put, the straighter and the more accurate your line is. Go ahead and get the dot in the other direction by reversing the pattern. Go down 1, left 1. Down 1, left 1. Once you have all your points, don't get in a hurry. Make sure you're using the right type of line. Because of the equal sign you see there, we're going to use a solid line. So let's go ahead and connect all of these dots with a solid line. And finally, all we have to do now is add the shading. And because this inequality says less than, we're going to go ahead and shade to the bottom of the line. So everything down here is going to be shaded. So once again, any point, this point here, this point here, this point here, all of these are solutions to the inequality. As a matter of fact, any point that I choose that's on that solid line would also be considered a solution. As long as it's on a solid line, we can consider it a solution. So, this is how we graph inequalities. Now, it's going to take a while for us to get comfortable with these rules here, so you might want to jot those down for future reference. Okay, so this is how we graph linear inequalities.